All right, so let's get into the main concepts of what we're talking about today. Loops and iteration. All right, quick, what's a loop? There's 160 of you. One of you has to know. Yes, sir. Excellent. So he said there's a chunk of code that repeats itself until a condition says to exit. Does it have to exit? Excellent. Would it be useful to have an infinite loop? Really? I can think of one really awesome place to have an infinite loop. What if you're trying to serve up a web page? Do you want to serve it up once, twice, 100 times? How many times do you want to serve it up? As many times as they ask. So do you ever want to stop your program? So there are cases where infinite loops are really good, but right now you probably won't run into too many of them. All right, so the first kind of loop that you guys have learned about is a for loop. Now, what's the idea behind a for loop? What do you do when you type in for, and perhaps this up on the screen? Why would you ever type this in? I'll keep it closer to my face. Is that better? Oh, the guy behind me showed up again. He keeps mirroring everything I say. Rude. All right. So what does this do? Why would you ever put a for loop like this up? Why would you ever use a for loop? Yeah, if you have a list and you want to do something to everything in that list. Perhaps you have a set of users, you have a set of numbers you want to do some arithmetic on, something you want to check. Loops are incredibly useful. It's anytime you have a collection of things and want to apply something to each one or check something about something or go on repeatedly the same chunk of code. All right, so for this particular instance, you just print out A, B, and C on separate lines. Not particularly interesting, but it exemplifies. Now, for loops are really good at definite iteration. What do I mean by definite? You know exactly how many iterations there will be. What's a situation where you know exactly how many times you need to do something? Sure, if you want to invite a certain number of people to a party, you want to send emails to say, hey, or text message or whatever your system you want to tie it into. There's a bunch of options. We've done a few things with algorithms and math in this section. And so perhaps you want to find the squares of numbers, or you want to find a number that's close to 0, or something like that, where you know, this is how many numbers I have, I don't need any more. Or perhaps you want to say, as long as, for 10 cycles, I want to continuously apply this. We'll show an example of what I mean by that in a second. All right. So then we come across this while loop. Now this is new. What's a while loop? In the back there.
Do an action until while something is true.
Excellent. So in a big way, the way he said it, you do something while something is true. And a big way that's different from a for loop is that it's indefinite. And the simplest way to see that is that what happens if you put true as the condition? While true, do something. Well, that's not going to end, is it? It's just going to go on. So you could put that into your web server when you're trying to serve up a web page. We could say, while true, wait for a connection. As soon as it's there, send them the web page. It's a very simple web server, but it would do the trick. All right, and its format is fairly straightforward. While some condition, and this is a Boolean expression that you have to put there, something that can evaluate to true or false. And then you'd execute some code block underneath that. So there's something big and different from this, from a for loop. What's different about the syntax even? You should even see it in the line. I can go back. There's the for loop. There's the while loop. What's different? Yes, sir. Okay, there's no list to go through. So what's the other part of the list that when you're going through, what are you doing with that list in a for loop? There we go. We don't have a variable that's iterating through the list. In the while loop, you just say, keep running this code block over and over again. So you can make a while loop like a for loop. You just have to create your own variable to iterate over and set the condition so it would exit at a certain time. You could say, you could start off, let me actually open up the code editor for this. Pressing the wrong button. Still getting used to Macs. A little bit different. All right, for an example, you could say n equals 0, and then while n is less than 10, n equals n plus 1. So that is every time I do this, I add 1 to it, and I print n. If I run this, it should print 1 through 10. Excellent. So anything you can do with a for loop, you can do with a while loop. Can you do it the other way around? Can you make an infinite for loop? With what you know so far, no, you can't. And it's actually kind of an esoteric thing to do. So for now, just think no. Any questions about while loops? Excellent. Make sure this is close enough so people can hear. Okay, and we already kind of talked about this. An infinite loop is when a condition is never false. Now this can happen intentionally, like in the case of a web server, or it can happen accidentally, as in the case of you just messed up your condition. Perhaps you say, while n is greater than 0, and then you keep just adding 1 to n. It's always going to be greater than 0. That's never going to finish, which would be kind of interesting. And it's actually kind of a novel computer science question. You can actually never write a program that can detect infinite loops. Yeah, it's kind of a fun problem. So unfortunately, you're never going to be able to have your computer tell you, like, oop, watch out, you might have an infinite loop here. Or you do have one. There's ways to hint at it. Okay, now this brings us into the algorithm section. What's an algorithm, guys? Excellent. A series of sequences that solves a problem. Now, what kind of algorithms do you guys know about? Could be anyone. E equals mc squared. That was more of an equation, less an algorithm. But if you, say, wanted to calculate what that is, how do you do multiplication on a computer? Well, that's an algorithm. It's not a very interesting one. It's just repeated addition. And there's trickier ways to do it. But yeah, that would work. Have you guys seen the Google machine that plays Go? That was very popular lately. People thought, oh, that's decades off when people would solve this game of Go because there's so many possible options to move, and Google already made a computer to beat it. So that's interesting for the computer age. Excellent. So you guys talked about two different algorithms. The first one was the 3n plus 1 sequence. Kind of a novel little thing. You type in a number, and you can implement it as a while loop like this. You say while n does not equal 1. If you ran this, it would be very boring. It would just exit right away. I should have put another number besides 1 there, but I wasn't thinking. So that'd just fall through. But say if you put 10, or 100, or a million, or any number, it'll go through this loop until it eventually exits. Do you know how many times it'll go before it exits? A priori, before you start. Do you know how many times it'll happen? Yeah, you don't know at all. In fact, do we know that it'll ever end for any number? No, not necessarily. This is an unknown question in math. It's, does this sequence ever terminate? Or are there numbers that it does not terminate for? And we've tested a lot of numbers, I think like 10 to the 200th. A lot of big numbers. And so far, they've all gone to 1. So this loop would eventually end for all numbers, basically, that you can represent on a laptop. And then you also talked about Newton's method. This is Newton's method for the square root. It's very handy. This is actually how a computer calculates a square root. Because it can't do it via, there's not some magical square root logic. You actually have to iterate through this particular loop. Now, this is a different implementation than you guys saw while reading. How is it different? Some of you have laptops. Scurry over to that page really quick. It does use an absolute value, but where is it using the absolute value? As a condition for what? Hmm? Mm-hmm. And she's saying, so the variables are used in that condition. But the condition is part of a while loop, right? In the example you guys used before, you had a for loop. It just said, do this a certain number of times. So why would this particular case be more useful or more dangerous? This version will actually tell you how close you are to the answer. That 0.001 says, I want my answer to be, I want the difference between my answer and the true answer to be less than that value. So we don't know how many times this will run. So what happens if you put in a number that has some error in it, that never gets quite below 0.001? Will it ever end? Yeah, it could possibly run forever. Which, say if you're trying to calculate, a square root on the fly as you're flying a plane, you wouldn't want it to do if it got a weird number, right? It'd just sit there and try to calculate square roots forever, and, well, the rest of your plane wouldn't fly so well, which would be bad. So in the case where you give it your best shot, you say, run this block of code 100 times, 1,000 times, and then give up. If it's not within accuracy, oh well. And there's also ways to kind of bound things a bit. You can say, well, tell me what the error is at the end after doing it 1,000 times. Or, better yet, just say if it does it more than 1,000,000 times, 1,000,000,000 times, stop. You're not going to get any better. You're stuck. And so we'll talk about ways to do that a bit later when we talk about more flow control. There's actually a way you can break a loop. You can say while it's true, and then there can be a condition inside that says just end it. It's done. Okay. Now one of the more complicated concepts. Inside a loop, you can have any block of code, right? You can put whatever Python you want to inside a loop, as long as it's indented. It'll run inside that loop. So, in principle, you could have another for loop, correct? And another, and you could continue this on until you get, eyes go crossed, which often happens with nested loops. 2 is a challenge enough, so we won't thrust anything too crazy on you guys yet. All right, this is really important for things like images. And in images, you have 2 dimensions. A one-dimensional image would be really boring. So we have 2. You have the width and the height. And if you want to visit every single pixel on an image, you have to move through each one. And I'm jumping ahead of myself. What's a pixel, guys? The definition's on the board. Yes, sir. Oh. Yeah, I actually like that definition. It's the smallest unit of information an image can have. And what qualities do pixels have? They have values associated with them. What are those values? In the back. Say that again? Color? Yes, colors. Which colors? Excellent. Why red, green, and blue? Yeah, they're good primary colors. They can be mixed to make a lot of other colors. Not every color, but that's more of a color science question. I'm colorblind, so I'm really in trouble there. Okay. And again, since an image is 2-dimensional, we want to visit, say, every pixel on an image. We need to have 2 different variables to iterate over. We need to do one for the length, or the width, and one for the height. And a way you can do that is you can nest iterables like this. So you can have one for I, and one for, you can have one for I, one for j. That is, you assign one to be the width and one to be the height. In this example here, it'll just print out all combinations of 1, so from 1 to 100 in both I and j, all pairs, and just go down. It'll take a lot longer, because every time the nest of the loop happens once, it'll happen once for every one of the outside loop. So this means your complexity just went up a lot. You're now doing a lot more than you were before. And on my slow laptop, I actually realized this when I was doing some of the problems that you guys did. Mine would time out. This is too slow. Had to increase the time a bit. So I'll show you how to do that in case you have a laptop as slow as mine, which I hope you don't. Okay. So now I want to do the pre-studio. And in the pre-studio, I'm going to ask you guys to help me build something that will tint the Luther Bell image red. Imagine you put on a pair of red sunglasses. What does that do to things you see when you put on a pair of red sunglasses? Mm-hmm. They could block out greens, but if it's tinting the image, just red's turned all the way up. That is, the red portion of your image is always there. The other colors might leak through, but everything's going to be quite red. Now you could remove the other colors. Not sure what that would be. I need to talk to somebody that knows more about colors than I do. Again, colorblind. You could probably tell in the clothes I wear occasionally. You're allowed to laugh at that. Good, good. Okay. What's the first thing I need to do if I want to start working with images in this interface? Excellent. There's the image. I'm going to see if I can make this a little bigger. That's pretty big. It might be too big. Yeah, that'll work. Okay. Now after I import the image, how do I load the image? I would look this up on the page where they talked about it. I don't remember all of my interfaces all that well, especially when they're new ones, and this one's a little bit different from the ones I've used before. Yes, sir. Yeah, we have to load it from the file, and we have to create a variable to assign it to. So let's call it img, and I say image dot load, right? And if I want to use the Luther Bell, it's Luther dot. Ah, you're right. Thank you. And then what's the extension on the Luther? Excellent. All right, now I also have to create another image to put everything into, right? That is if I want to copy it over. I could do the same image. Actually, let's keep it the same image for now. So I need to create a window to display stuff in. How do I do that? There's a window. Is that it? Image win? All right, here, I'm going to look it up on here. That way everybody can see. So here's an example, some code I threw together before. All right, image win. Yep, that's exactly it. All right, this is the code you'll be using for the studio, so we can go ahead and grab stuff from it. Oh, this should be indented. Oops. You guys will have to indent that row, this block here, to make sure that it works right. Otherwise, this would be a syntax error. You can't have a for loop with nothing underneath it and butt it up against another loop like that. I'm just going to copy this bit so we can actually just see our image. Okay. If I run this, I should be able to scroll down and see the Luther College bell. Fantastic. Now I want to make sure every pixel is colored red. The red is turned all the way up. How do I do that?
Set your RGB values to 255.00.
Well, that would make the entire image red. That is, if you turned up the red all the way to 255 and left the other ones at 0, that'd just paint the entire picture red. But I want to tint it. I want to turn up the red channel only and leave the other channels at wherever they are.
Leave the red value the way it is and remove the green and blue values.
I could remove the green and blue values, and that would just keep the red channel around. We could try that out and see what that looks like in a moment. But I need to visit every pixel, right?
Yes.
So what's the first thing I need to do? A for loop. So what's your favorite one for the x direction, the width? Well, I need a variable first. That's not like x. Gives it the x in range. And what's the range I'm going to be going through, guys?
0 to 255.
Get width. Excellent. And if I put another for loop nested inside that, that means for each x, it's going to also do this for each y. In range, image.get height. These here, the parentheses. You mean this here, right? This one right there? Ah, yeah, so, yeah, that's the parenthesis that ends the arguments to range. Range, if you give it one option, will just say go from 0 to that, right before that maximum number. If I remove the range, I wouldn't have to put it there, but then it would say for x in the number, I don't know, 400, if it's 400 pixels wide. And that wouldn't work. Instead, I want the range of all the numbers from 0 to 400. And same thing for whatever the height might be. All right, now how do I extract a pixel from an image? It's image.something. Get pixel. Is that correct, or is it underscored? And then how do I access a particular pixel?
Coordinates X and Y.
Yeah, the coordinates x and y. Exactly. Thank you. Only one comma. And we have to assign this to some variable. Let's say p for pixel. All right, now how do I access the different colors inside the pixel? It's p dot something. Yes, sir. Let's get, and then the color name, right? So I could say get red. Okay. All right, so we'd say red is that. Now let's make sure that my spacing is correct. All right, so now I have variables that store red, green, and blue. How do I create a new pixel that has the values I want to toy with?
You have to create a new variable.
I do. Let's call it new pixel, new p. And that would be image.pixel, right?
Yes.
And it takes red, green, blue as its arguments. So what do I want the red to be if I want to tint it red?
255.
Set it, 255. And then what's the, it's red, green, blue. So green, blue. Okay, now I have this new pixel. Is it associated with anything yet? This is floating off in the ether in space by itself. How do I stick it back into the image? Okay, on what? And then I can give it a new p, right? What am I missing?
X and Y.
Yeah, it's where I want to put it. Excellent. So I should just be able to run this, and we'll see what happens. My browser seems to have locked up. I'm asking it to do way too much here, I think. Ah! There we go. Can zoom back in, because it'd be nice. Excellent. There we go. There's a red tinted image. So let's just play with this for a second. What happens if I remove the green channel and the blue channel and keep this one at red? Well, first it's going to freeze my browser. For a while, apparently. So this is Python implemented in JavaScript running on a browser, so you can see the potential problems that could happen with that. There we go. That is just the red channel. So this can be really helpful too. In a lot of cases, you'll be interested if you're doing like image processing and stuff like that. Certain color channels are more helpful than others. For instance, Google just created a machine that can detect diabetic retinopathy in the back of your eye. And the image is very red. And there's a lot of red in it, so it's not that useful. But if you look at the green channel, you can actually see interesting structures. So you can kind of sort out all the other stuff. And this is true for a lot of areas as well. All right, so this is kind of an introduction to image processing. And to further that goal, I'm going to let you guys go off into your groups, and I'm going to have you look at blurring an image for your studio. Now this is probably going to be the most challenging studio you've done so far, and it's going to take a little while for you guys to do. And I suggest you work in groups and try to figure out what's going on. Right, and the basic concept of blurring an image is if you're looking at a particular pixel, you take its color values and you mix it with the color values of its neighbors. And you do that using this kind of stencil or grid. And the way you do that is you take the one in question, the one in the center, that is the pixel you're going to replace, and you multiply all of its color values by 8, the one above it by 3, and the same goes for left, right, and on the bottom, and then you add them all up and divide it by 20. And then what you'll get is the weighted average of the pixel in the center with all of its neighbors. And you can increase the ones on the side, and that'll increase the blurring. You can make it smaller, and it'll decrease the blurring. And the idea is you get to weight its neighbors more strongly or less strongly to change the blurring. You could even do something completely kooky by saying, I only want to blur left, blur right. I'm curious what that would look like. I've never tried. Okay, thanks. So if you struggle with this, that's okay. This is a hard problem. Some weird stuff is going to happen. I'm going to warn you about it right away. What happens if you try to blur a pixel in the center of the image? Its neighbors are clear, right? There's the neighbor above it, below, left, and right. What happens if you come up against an edge? Or worse yet, a corner? What if you're at the first pixel that is 0, 0 in the upper left-hand corner? It doesn't have all of these neighbors, does it? So when you're writing the block at the center of your code, you can't let it apply to everything equally. You can do it to everything on the interior, but as soon as you get to an edge, you're going to have to apply a separate set of rules. Now, the naive way to do is to say, well, stuff on the edge isn't going to blur strongly, so don't blur it at all. And if the image is higher enough resolution, you'll never notice. Or what you could say is that the edges are a different condition. You have to apply different rules to the edges than you do the interior. So I'll let you play with that for a little bit. Please ask questions, fight through it. They're working with different conditions and how your loop may not always apply is a very strong and powerful concept to make concrete. So, get started.